easy to build a general-purpose oxygen generator. It can be used to feed small torches, as well as other jobs in the house or shop. This generator should be installed in a backyard outside the house to provide exhaust for hydrogen gas, which we will not use. And you don't need to go shopping for hard-to-find or expensive components at all. To begin with, you need a piece of PVC pipe, about 4-inch diameter and about 10 inches long. These sizes are not critical and largely depend on the size of the rest of the components you'll be using. Then you need a transparent plastic box with an airtight cover, similar to boxes used to store packages in the cupboard. Another material you'll need is a PVC reducer coupling to fit the PVC to a thin, transparent type hose with 1/4 inch inside diameter. In order to hook the hose, use a plastic bar fitting of the proper diameter, screwed or glued to the PVC pipe adapter. This hose will carry the oxygen into the room or area where it is going to be used. A small PVC ball valve must be placed at the free end of the hose in order to control oxygen flow. You also have to get yourself a PVC swamp cooler float. Also, you need 2 pieces of insulated 10-gauge copper wire in 2 colors. One length is red and the other is black. We'll also use a pair of 10-inch long stainless steel screws. Each of the screws will carry a pair of nuts for attaching it to the copper wire. We are going to need a small transformer for stepping the line voltage down to about 24 volts and a 3 amp 600 volt diode bridge. Let's first look at the assembly of the oxygen producing cell. First, the adapter must be attached to one end of the PVC pipe. It must be perfectly sealed without any leaks. Next, strip the insulation off the red wire so it can be curled as an eyelet. This eyelet should snugly fit on one end of the stainless steel screws and kept in place by the 2 nuts. You must cover the copper wire with some waterproof sealant so it does not touch the electrolyte. Then fasten the screw to the inside of the PVC tube with a plastic strip so that the water inside the PVC pipe can be pushed down by the oxygen produced, but preventing the oxygen gas from escaping outside the PVC pipe. Next, the PVC tube adapter should be attached to the lid of the box near one of its ends by means of the plastic bar fitting by using rubber gaskets to prevent any leakage. Please check the PVC oxygen generating cell has enough space to be suspended an inch away from the bottom of the box. If necessary, the PVC pipe can be slightly trimmed in order to meet this condition. The assembled set should look like this drawing. At this time, the cell is ready to generate the oxygen, but it's necessary to add an output for hydrogen, a gas also generated in this process. The black cable must be attached to the remaining stainless steel screw by using this other screw and its pair of nuts and waterproof sealant. This screw can be suspended by attaching the black wire to the lid of the box. This screw should be completely covered by the electrolyte at all times. At the right end of the box, a hole is made so as to fit a 1-inch diameter PVC pipe. This pipe should be about 6 feet long in order to provide an exhaust for the hydrogen to the outdoor air. An elbow arrangement is placed at the top end of this pipe to prevent rainwater from entering. You also have to make a hole in one side of the box to install a swamp cooler float connected to a cold water pipe through a piece of thin hose. The box lid and all gas and water fitting must be perfectly sealed and free from leaks. The next step is to dissolve about 1 ounce of sodium hydroxide, NaOH, in a large glass of water and then empty it into the plastic box. Now you must open the valve filling the float so that the box is filled to the necessary level as shown in the drawing. The oxygen outlet valve must also be opened to allow air to escape from the oxygen generating cell and have the stainless steel screw inside the PVC pipe covered by the water. Next, comes the electrical connection. The transformer and the diode bridge are used as the power supply. The connections are very simple as seen in the drawing. The ends of the transformer secondary winding go to the diode bridge at its AC input, and then the positive terminal of the diode bridge goes to the red wire of the oxygen generating cell, and the negative terminal of the bridge goes to the black wire from the hydrogen generating screw. The transformer primary goes, as usual, to a regular outlet, either 127 or 220 volts AC, depending on your country. If the plastic box is transparent, bubbles should be seen to come off the hydrogen generating stainless steel screw. The bubbles should be abundant and must form a cloud around the screw and begin to rise and burst on the surface of the water. These bubbles are hydrogen gas that, being lighter than air, goes out to the free outdoor air through the pipe we have installed. Likewise, oxygen bubbles are also being produced inside the generator cell around the oxygen generating screw. This gas is oxygen, which must be coming out of the hose going out from the cell and into the house. If we leave this valve open, oxygen will continue to flow as long as the water covers both stainless steel screws. Since we are extracting oxygen and hydrogen from the water, the level of water will slowly decrease, but the float valve will keep it constant. On the other hand, if we shut off the oxygen outlet valve, the pressure inside the cell will begin to raise, which will cause the water level inside the cell to drop, thus decreasing the area of the screw covered by the water, thus reducing the amount of oxygen produced. If the water level drops low enough, the reaction stops. If once again we need more oxygen gas, we simply open the valve, the oxygen stored in the cell begins to come out from the cell, the water level goes up, water covers the screw, and the reaction starts again. This means we will have a machine which can produce oxygen continuously as long as it has a constant source of water and an electrical power supply. Please keep in mind that the hydrogen generating screw must be completely covered by water at all times. Whenever the oxygen outlet valve is shut off, the water level in the box goes slightly up, so there should be plenty of room for water to flow out of the oxygen generating cell to stop the electrolytic reaction when needed. None of the values or dimensions given are absolute. For instance, you can use more than one stainless screw per electrode for more contact surface and more oxygen gas produced. The voltage supplied to the electrolytic cell can also be higher. On the other hand, a large box and a larger oxygen generating cell can be used. The principle will remain the same. A word of caution. Both hydrogen and oxygen can be very dangerous and cause explosions or fires if not handled properly. A room full of oxygen can lead to the ignition of some flammable materials, since pure oxygen enhances combustion of most materials. It can even make certain metals catch fire. Furthermore, hydrogen gas is highly flammable and can pose a risk of fire or explosion. When handling any of these gases, be sure to avoid being near open sparks or flames. I hope this information has been helpful to you. Thanks for watching and please subscribe to my channel. Ciao,